So today we are going to be talking about rotations. You're going to be able to rotate counterclockwise 90, 180, and 270, and clockwise 90 degrees, which is the same as 270. Are we okay?
Yeah.
So rotations are a little bit more difficult than what we learned on yesterday, but for the most part, if you understand perpendiculars, then you should be fine. Okay? If you understand perpendiculars, then you should be fine. So first of all, we're going to graph the preimage and its image after the given rotation. So first of all, thing we need to understand is clockwise versus counterclockwise. Because you guys are so used to the digital clocks, you guys don't really see, the analog, I guess is what it's called, clock anymore. So remember, that is clockwise. And rotating this way would be counterclockwise. So you'll see CW for clockwise, and I think it's CCW for counterclockwise. Just so you guys are aware. So if you didn't already know that turning motion there, a rotation is a turn of some sort, but that's what it means to be clockwise versus counterclockwise. So first of all, we have a quadrants here. Do you know how many degrees are in the whole entire quadrant if you go in a circle here? 360, because it's a circle. So each one of these quadrants is 90 degrees, if that helps you, because 90 plus 90 is 180, 180 plus 90 is 270, 270 plus 90 is 360. So that kind of gives you an idea of where you're going to be going after you plot the points. So first, let's plot these points. Let's plot 3, 4, 0, 1, and 2, negative 1. So go ahead and do that and connect them. I'll get you guys straight edges in just a second. Let me get the points plotted first, and then we'll do that. All right, so if we're going counterclockwise, and we're rotating, and we're always going to be rotating about the origin, just so you guys are aware, and you're rotating 90 degrees, A would have to move from this quadrant into that quadrant. Do you guys agree? If B is on the line here, it would have to rotate to this line over here. And C would have to rotate up to there. Do you guys kind of see the whole 90-degree thing there? So which one of our lines, parallel or perpendicular, used a rotation? Which lines use a rotation, parallel or perpendicular? Which one? Parallel uses a translation. Perpendiculars use a rotation. So you can go from the origin and count the slope. So I'm going to start with A's slope. So A is up 1, 2, 3, 4, right 3. So A has a slope of 4 over 3. What would the perpendicular slope of A be? Go ahead. Good, Logan. So we know that A needs to end up where? Where does A need to end up? Which quadrant? 1, 2, 3, 4. Which quadrant does it need to end up in? 2. So we need to do the opposite reciprocal slope because we're rotating. Remember, perpendiculars are rotations. 90 degree is perpendicular, right? 90 degrees means perpendicular. So instead of going 4 over 3, we're going to go 3 over 4. Do you see that's a negative slope there? 3 over 4. And A would end up 1... Red shows up, right? Up 3 over 4 over here.
Wait, is that A or B?
I rotated A. Because A is up 4 over 3. So the perpendicular of up 4 over 3 is negative 3/4, so we went 3 over 4. We went up first, though, Ian, because we knew we had to go into this quadrant. Do you guys understand why I didn't go down instead? You have to know which quadrant you're going to, so you know which way to go, like up or down. Does that make sense? So if you're going to one of the upper quadrants, you're going to want to go up first. All right? Okay, B is right here. And B's slope is currently undefined. It is up 1 over 0, right? What is perpendicular to that? 0 over 1, right? So if we go up 0 over 1, and we need to rotate which way? Where should B end up? Where did we say B should end up? This way, right? So we need to go to the right, the left over here, right? So this should be negative because it's positive before. So this is B here. All right, next one. C. Always going from the origin. Notice, where am I always counting my slope from? The origin. So the slope of C is down 1, right 2. Down 1, right 2. What's perpendicular to down 1, right 2? Just 2 over 1, right? So a few things. Usually we tell you should simplify slope, right? Usually we tell you that. Don't simplify. Leave the numbers the same, all right? So even if you have up 6 over 8 and you go to reciprocate that, do 8 over 6, negative 8 over 6. Do not simplify at all, okay? Because you need it to end up in the same spot. So that's why you can't do that. So in this case, we know C should end up in quadrant 1. Do you guys see that? So we're going to go up 2 over 1. And connect your points. So this is a rigid transformation, meaning it doesn't change shape. But does that look like it was rotated? Does that look like it was twisted over that origin there? So those are the things that you're going to be looking at today, are these things. So it's a little bit harder than it was yesterday, right? Not super difficult, but still harder. There are rules that we will be discovering here. So if you want to look at some of these ordered pairs, maybe you can discover the rules with me a little bit. So what is A prime's new point? What is A prime's new point? What are we at? Negative 4, 3, right? B is at negative 1, 0. And C is at 1, 2. What do you notice happened with those ordered pairs? What happened with those ordered pairs? Because there are rules. So if you are really good at memorizing, you can memorize the rules, or you can just always do this slope action. I like doing the slope. I hate memorizing things. Okay? But if you like to memorize things, you can use the rules. Katie, what do you notice?
The y's change slope after being switched with x.
So x and y switch places, but what happens with the y value? So it's an opposite of the y value, comma x is what's happening there. Do you guys see that? They switch x and y and make the x value opposite. Do you guys see that? So that's kind of the rule for 90 degrees counterclockwise. Again, if you can't memorize the rule, there's two things you can do. Either just do everything with the slope, or do one of the things with the slope and figure out what the rule is again to get the other points. Does that make sense? Like if I was going to use the rule, I would probably first test it out with the slope and then say, okay, yeah, this is the rule. I'm going to go ahead and do the other points. Does that make sense too? So you guys have kind of multiple ways of doing this. Okay, 180 degrees clockwise is the same thing as 180 degrees, right? Because you're going to end up in the same spot, right? If I'm starting here and going 180 degrees, that's 1, 2, right? Quadrants, because it's 290 degrees. Remember, 90 degrees is going to the next quadrant, so 180 degrees would be going over 2 quadrants. So those are going to be the same thing there. So go ahead and plot your points. Huh? Did I do it wrong? Yes, I did. Thank you, Cameron. Are the other 2 points okay? Thank you for telling me now instead of before I started the whole entire problem. I appreciate that. Okay, does that look right to you guys now? See? Like I said, some of your mistakes are going to be just because we don't plot points right? We make our mistakes when we're rushing through things. I do the same thing, guys. Okay? I understand. All right, so if we are rotating 180 degrees clockwise, that means that n needs to go from this line. Which line do you think n is going to end up on, I guess is what I'm trying to say. Will it be on the positive x, positive y, negative x, negative y? We're thinking n should be about here, right? N prime should be somewhere over here. Where should p prime become? Quadrant 1, 2, 3, or 4? If it's going 180 degrees. Quadrant what? Yeah, 1. So do you see I haven't done any rotations. I'm just making sure that when I do my work, it ends up in the right spot. Does that make sense? I'm kind of thinking ahead. So where would m have to end up? 1, 2, 3, or 4? 4, because it has to end up in 2 away from the quadrant it's in. So we know kind of where those pieces are going. Do you guys see how I'm kind of looking ahead to where they are going? All right. Is 180 degrees perpendicular? Is 180 degrees perpendicular? So are we going to be doing an opposite reciprocal slope? No. The slope is going to stay the same. You just need to go in the directions it should go. Does that make sense? So it would still have like an opposite kind of effect going to it because of where you're going. But it's more about just keeping that same slope and knowing where you're heading. So n is currently here at up 3 over 0, right? We know that n needs to end up where? Down here, right? So the slope is just going to become negative. So it's just going to be negative 3 over 0. So you're going to just go down 3 over 0, and n ends up here. So 180 degrees is just like switching the sign, because you're going from a positive axis to a negative axis. So that's why that's happening that way. M is up 2, left 4. So this could be simplified.
No.
Oh, I only up 1. Thank you. Up 1 over 4. Up 2 over 4 could be simplified, though, just so I say that. Don't simplify slope. So m is 1 over negative 4, right? We know that m needs to be down here, right? So when we do this, we know that m needs to go down 1 over 4 to get into this quadrant. So notice, did I change the slope at all? That's still negative, isn't it? So it isn't just changing the sign either. You just have to know where you're going. Do you understand why I put these letters here now? So 180, your slope does not change at all, but at least I know where I'm going, right? So m ends up here. You will learn the rules, don't worry. And then p is down 2 over 2. Can you simplify down 2 over 2? Should you simplify down 2 over 2? We don't simplify the slope. We never simplify the slope. Where does p need to end up? In which quadrant? Okay, so Kylie, what would we need to do from the origin if p needs to end up here?
You're going to go up 2 over 2.
In which direction?
Right.
Yeah, up 2, right 2. So since you know where you're going, you can put it there. So that is p prime.
Would you count off if you didn't label our points?
You need to label your points. Like, that is part of the test, okay?
Okay.
Now, don't have all these random lines that I have drawn in here. That's more for the notes, so you guys can see what I'm doing. Does that make sense? The only thing you really need are the 2 triangles. But you'll notice that they are rotated 180 degrees, right? All right. 90 degrees clockwise is the same as what? Can somebody tell me what that would be the same as, 90 degrees clockwise? How many degrees counterclockwise would that be the same? 270 degrees counterclockwise. Oh, we didn't discover the rule on the other one. Sorry, guys. So M is now at 4, -1. N is now at 0, -3. And P is now at 2, 2. What do you think happens with this one then? What's the rule? You just switch the signs. Yep. Just -x, -y. 0 isn't positive or negative. That's why the sign doesn't matter there. So again, if you're a rule person, I'm telling you guys the rules as well. Does that make sense why I'm doing that? And you're kind of figuring out what they are in the end there. Okay, now 90 degrees counterclockwise or 270 degrees, 90 degrees clockwise or 270 degrees counterclockwise. So go ahead and plot those points. I put that in the wrong spot. Okay, before we start this one, we're going to talk about where they're going to end up. So, Jill, if we're going 90 degrees clockwise, where would T end up? In which quadrant? 1, 2, 3, or 4? If you go, good. So T is going to be somewhere in this quadrant, right? Greg, where would R end up? 1, 2, 3, or 4? If you're going 90 degrees clockwise. So it's 1, 2, 3, 4.
4, right?
That would be counterclockwise. You're going clockwise, which is this way.
Alright, so then it would go 2.
Yeah. And Abby, where would S end up? Yes. So at least we know where our line should be going. So 90 degrees and 270 are perpendicular, meaning the slope needs to be perpendicular. 180 means the slope needs to stay the same. Does everybody understand that? So 90 and 270, you do a perpendicular slope. 180, you do the same. Does everybody get that when you're doing the rotations? Because 270 is a version of 90 degrees. So if T's slope is currently from the origin up 2 over 2, what is the perpendicular to that slope? Negative 2 over 2. Where does T need to end up? Where does T need to end up? Iku, where does T need to end up? Okay, so how are you going to do that from the origin? What are you going to do? Go down 2, right or left? Right 2. Doesn't that put it in the same rotation spot then? So right 2 over 2. Okay, Casey. S's slope is up 2 over 1, right? Do you see that? So S equals 2 over -1. So what is the perpendicular to that, Casey?
1 over 2.
Okay, 1 over 2. And we need it to S to end up over here, right? So from the origin, what are you going to do?
We're going to go
Up 1 in which direction? Right, because you need it in this right quadrant here. So you would end up going up 1 over 2. Okay, Daniel. R is down here, and we know it needs to get up here in quadrant 2. R's slope is currently down 3 over 1. R's slope is currently down 3, left 1. So that's 3 over 1. So what is the perpendicular to that? It'd be -1 over 3, yeah. So R needs to end up here. So what are you going to have to do first from the origin, Daniel, then? Up and down is first. So not left 1. Up 1. Which direction 3? Left 3. Okay, and then connect your rotation. Does that look like it was just fun? All right, so before we move on to other examples, Rob, you should be taking notes. What questions do you have for me? I don't know how come that printed like that. Do you guys have like on the one of your slides like something really weird? I don't know why that happened like that. Sorry, I don't know what happened on that slide. I know, I printed something weird and I have no clue how that happened. What's up?
Is there a rule to this?
Oh yeah, what is the rule for this one? That's a good point. What is the rule for this one? So r prime is now at negative 3, positive 1, right? S prime is now at 2, 1. And t is now at 2, negative 2, right? Did I do that right? Yes. So what happened there? You switched x and y, and which one became negative this time? Not the y, the x value, the original x value. So you switch x and y, and the original x value is the one that changes signs. So those are your rules that are on that very last slide. I probably won't even go over that slide with you guys. I have no clue what happened on the notes, though, on one of those pages. I'm sorry. Again, if you are not somebody that's good at memorizing and you understand what I just did on all those graphs, just do that. I do that more than using rules. For me to memorize that, it seems pointless to me when I can just, figure it out that way. But if you're really good at memorizing things, I can see why that would be more beneficial. Does that make sense? I just really don't have their mind to remember all of that stuff anymore in my life. All right, graph triangle JKL with vertices 2, 2, 4, negative 5, and negative 1, 6, and its image after a 180 degree rotation about the origin. Does it really matter that it doesn't tell you if it's clockwise or counterclockwise for 180 degrees? No, because 180 degrees counterclockwise and clockwise is the same. So, 2, 2, 4, negative 5, and negative 1, 6. If you are one of the people that like the rules, what is the rule for this one? What is the rule for this one if you want to use the rule? You just switch x and y. Do the signs change at all? Do the signs change at all? Look back on that first page. No, you don't. You just switch x and y, right? Or do you change signs?
You just change signs, you don't switch x and y.
Okay, so we said that wrong. That's why. So you just do negative x, negative y, right? Is that what we discovered on this page? It was negative x, negative y. So if you like the rule, go for it. If you're using the slope, should your slope change? Does your slope change with 180 degrees? No. No change. You just need to know where you're going. So if I know where I'm going, that helps. So Lindsay, if I'm going 180 degrees, where would point L end up? 1, 2, 3, or 4? 1, 2, 3, or 4?
4.
Yeah, because you're going 2 quadrants away, so L should end up here. Morgan, if I'm rotating, J should end up in which quadrant? 2 is right here. Is that what you meant? So it's currently in 1. It needs to go 180, which is 2 90-degree rotations. So 1, 2, which would that be quadrant 3. Okay? Carmichael, how about K? Where would that end up? So that's a 90-degree rotation. We would need 180. So one more would put us in quadrant 2. You guys got to be careful. 180 is 2 90-degree rotations, okay? All right, so we know where we need to end up. So L has a slope of up 6 over 1 And we know where it needs to go. So Gabe, from the origin, what am I going to need to do to get L down here? Do I have to go up or down 6?
You have to go down 6.
We have to go down 6. Do I have to go right or left 1?
Right.
Right 1, and that puts us in the quadrant we want to be. Cameron, J has a slope of 2 over 2, and we need J to end up here. Do you see that? So from the origin, what are you going to do?
Go down 2 and over 2.
Which direction? Over. Left 2. Good. Okay. K. Notice we also did we simplify the slope? Did we simplify the slope? No, please do not do that. So K is down 5 over 4. So Ian, how would I get K up here? What would you do? Up or down first? Up how many? 5. Over which direction? Left or right?
Left.
Left.
4.
1, 2. All right. Did any of you just switch the signs? Did any of you just do that? And did you notice that that is negative 2, 2, negative 4, positive 5, and positive 1, negative. Why didn't that one work? Oh, you are. I'm looking at the original point. That's why I got confused. Yeah, positive 1, negative 6 does work. I was looking at the black point instead of the pink point, so I confused my own self. So if you just switch the signs, that also works if you're good at memorizing. All right, next one. Graph triangle JKL with those vertices, and it's going 90 degrees counterclockwise. So 90 degrees counterclockwise. So if you go back to our first page, if you look at our first page, 90 degrees counterclockwise was negative y, comma x. So if you want to remember that rule, you can. So again, going back to our first page, it was negative y, comma x. Or the slope needs to be perpendicular, depending on how you want to look at that. Oh my goodness, it's already 9:05. So we go to 4, 2, and we have a point J there. 3, negative 1, down there, and negative 5, 4, up here. So J currently has a slope of up 2 over 4. So Austin, what is the perpendicular of up 2 over 4? Negative 4 over 2. And if we're going 90 degrees counterclockwise, where is J going to end up in? 1, 2, 3, or 4? 2. Okay, so tell me how to do that from the origin then. What would I do? Up or down 4? 1, 2, 3, 4, and then how many? Left or right? Left 2. Which is the same thing as taking the point and doing negative 2, 4. That is at negative 2, 4. That works that too. L currently has a slope of 4 over 5. Helena, what's perpendicular to negative 4 over 5? 5 over 4. So if you're doing it that way, where should L end up? In which quadrant? In quadrant 3. And will you go up or down first from the origin? So we go down 5. Which direction? Left or right? Left 4. And again, if you do the whole negative, oh, I'm looking at the wrong one, negative x comma y, you'll see that we do get it at -4, -5, right? And then finally, k has a slope of -1 over 3, Lindsay. What is perpendicular to -1 over 3? 3 over 1. Where should k end up? 1, 2, or 3? 4. Sorry, I forgot 4.
Like what?
1, 2, 3, or 4.
2?
K's right here.
Oh, it's just 90.
Yeah, so 1 above it. Perfect. That's number 1. All right. So how would you do that slope then from the origin? Would you go up or down first? From the origin to get k up here. Would you go up or down? Up. 3. Which way? Right 1. So do you guys see both ways you can do this? All right. So I think you guys should be fine without doing the other examples there. This one here, I don't even know what even happened on it. But it's okay. So listen to me. If you guys have compositions on your homework, you're going to have 3 images on your graph. You'll have the original, the next one, and then you're going to compose that one again and do the next one. We'll talk a little bit more about that Monday. That should not be on your quiz. I'm not 100%, but that should not be on your quiz. This is the lesson for Monday. And then if you are somebody that's using the rules, do you guys see this page here? The rules are all here. And remember, rotating 270 degrees counterclockwise is the same as 90 degrees clockwise. We talked about that on the first page.